So in the previous video we have connected the different buses using transmission line, and we have also connected the generators to our two buses. Number one is swing bus and bus number two, which is a PV bus. Okay, so up to this point we have used all these parameters in our system. In problem, we wanted to determine the voltage magnitudes. For that we have used these bus fields to show the voltage magnitudes. Our two buses are having 1 per unit angle 0, which is a flat start. Now also we wanted to determine the generator unspecified active and reactive power using polar form of Newton-Raphson method. Also we want to do, if we wanted to see the line flows, then we will use a transmission line field like this, transmission line field, and click on the transmission line. You will see this type of field window. Digits to right of the decimal we will use 3 decimal places. Then we wanted to see megawatt flow, so megawatt flow will be seen here. Then we will see, again select our field as transmission line field. Also we wanted to see the MVAR flow, so like this. Also we wanted to see the MVA and MVR flow to this bus, so again selecting the field here and select megawatt and MVR flow. Decimal places will be 3. So like this we can see MVA flow and MVR flow. Also if you wanted to see the losses in the line, then we will see the transmission line field. Click on the transmission line and select megawatt losses. So here we can see some megawatt losses. Then again selecting our transmission line field and MVR losses. We'll have some MVR losses here. Do not confuse with these values because it will change as the load flow will occur. And we will select all these fields for all the 3 lines. So till now we have connected all of our buses and we have used all the fields to view the results. Now you can go to the run mode. Before going, we can save our file by Control S as load flow 3 bus. We can save to a specified location somewhere like this, anywhere you wanted to save this program. So we have saved with load flow 3 bus. Now going to run mode. Here we have case information and the tools. In tools you can see solve, power flow, Newton-Raphson. Also we can use different type of methods like polar Newton-Raphson method. So selecting polar and R, we can see our results here. Now we will restore user state or reset to flat start. So this is our model. If you see here, now after doing reset to flat start and going to draw, show full, now run mode. I'm going to again run the program and solve for polar Newton-Raphson, and when we click on solve Newton-Raphson you can see these type of results. So you can see here different generators. Now generator number 1 at which is a slack bus is working at 21 megawatt and 4 MVAR power, and this generator is delivering 100 megawatt and 7 MVAR. Also the line flows, you can see how the flow is occurring. Also you can play and see how the load flow is being done for this system. So I hope you will enjoy this video and you can solve more problems on the Newton-Raphson and load flow analysis. Now what happens if the loads will increase? So let us check what will happen if these load will increase. So select, going to our draw, we can select this field and we will use delta per click of mouse as 5. So here you can see the field shown here will have 2 buttons, like you can see here. It is having one for up to change the power or the load to 105 megawatt, 1010. In this way the load will change. Right now it is 100 megawatt. Also I will use this field here and I will change the load per click of mouse as 10 megawatt. So let us see what will happen if this loads were changing. From this zoom in and zoom out option, use show full. Then after that, if you go to the edit mode, we can put it above and we can enlarge these fields to view. Right now only the megawatt load is increasing. So I hope you can see it now in a much better way. Going to run mode. So this is the initial load flow which is being done using polar form of Newton-Raphson, and this is how the electrical power is being transferred from one bus to other bus in a loop type of network. Right now I will increase the load, and you can see there will be a changing load flow. Also, if I increase this load flow load value here, then there you can see the value of the supplied power by the generators is changing. So in this way you can check for any type of load configuration. I will take the system back to 100 megawatt 50 MVR and 20 megawatt 10 MVR, and this is the load flow. You can see here the generator outputs: 100 megawatt 7 MVR, 21 megawatt 4 MVR. The line flows, you can see here the losses in the transmission line, which are seen here as 0.217 megawatt, 0.041 megawatt and 0.0441 megawatt. Also, we can see the bus voltages which we want to determine. The bus voltage for bus number 1 is 1 per unit, angle 0.00 degree. The bus voltage is 1.00 per unit and 0.91 degrees. The bus voltage at the load bus is reduced because here is only a load and no reactive power support, so 0.98 per unit and minus 2.38 degrees. So I hope you will enjoy this video, and you will see the video for load flow analysis for 3-bus system, first part, and this is the second part, and I hope you will enjoy both the videos. And I will like to know from you that how much do you like these videos, and I will do upcoming videos for you too. So till now, stay tuned to the channel GECBANSWARA, and thank you very much.